Hey everyone, and welcome. Today we're going to take a deep dive into one of the most important, but maybe least talked about, concepts in AI right now. We're going from a simple idea, a blueprint, all the way to a full-fledged business. Let's jump right in.
Okay, look at this number. $8 billion.
That's the projected market for autonomous AI agents. Now, right now, all you hear about is prompt engineering, right? But the real secret to unlocking all that value, it isn't just about asking the AI better questions. It's about building a better factory. And that brings us to the main event, the AI data factory. So what is it? Think of it as the engine room of AI, the place that takes all the messy, raw data from the internet and turns it into high-grade fuel for AI systems. So, to put a finer point on it, an AI data factory is basically a continuous automated pipeline. Its whole job is to go out there, grab raw data, process it, clean it up, and then turn it into these beautifully structured, high-value datasets that you can actually use to train or power an AI.
And you know, the factory analogy really works perfectly here. In a normal factory, you've got raw materials. For us, that's raw internet data. Instead of big noisy machines, you've got code, scrapers, and processors. The assembly line? Well, that's your automated software pipeline. And the finished goods aren't iPhones. They're perfectly clean, AI-ready datasets. And you distribute them through software services or AI agents. Okay, so let's pop the hood on this thing. Let's deconstruct that assembly line and see what's actually going on inside the factory.
When you boil it all down, it's really a four-step process. First, you have to collect the raw data. Then you process and clean it. And believe me, that means getting rid of a lot of junk. After that, you transform it into a format the AI can actually understand. And finally, you package it up, ready to go. And when we say collect, we're talking about a massive operation. The data collectors are pulling information from everywhere you can imagine. News sites, dense research papers, statistical databases, APIs, GitHub, public archives, you name it. We're talking about an endless fire hose of information being pulled in constantly. So this is how all that raw data actually becomes a product you can sell. It gets packaged into different tiers. You've got tier 0, which is just the raw, messy stuff, cheap but hard to use. But as you move up the tiers, that data gets cleaned, categorized, and quality controlled. Its value goes up at every single step, until you hit tier 3, which is these super valuable, often domain-specific proprietary datasets. But you know, a simple, automated assembly line is really just the start. The real next-level stuff happens when you give the factory an intelligent brain, when you go from being just automated to being truly adaptive. So what's the difference, really? Well, a basic factory just follows the rules you give it. It sorts data by date or some simple ID. If something breaks, it just stops, dead in its tracks. But an adaptive system, one with these reflective agents, is way smarter. It processes things iteratively, always checking its own work for quality. It sorts data based on relevance or what the user might actually want. And here's the kicker. When it hits an error, it doesn't just give up. It tries to figure out why it failed and heal itself. And the magic behind that self-healing ability is something called a reflection loop. This is the core of its intelligence. The agent does some work, creates a draft, and then it literally stops to think. It critiques its own draft against the original goals. And only after that self-check does it finalize the output. It's a constant process of self-correction. Now, all of this sounds pretty neat and tidy in theory, right? But the actual reality of building these things can be, well, a total mess. Let me walk you through a real-world debugging story that shows you what it's really like in the trenches. So here's how it goes. First attempt, your script to process a bunch of data just runs out of memory. Crash. Okay, fine. Attempt 2. You rewrite it to be way more memory efficient. Now it runs, but it fails with a totally new error, module not found. So you figure, okay, the code must be old. Attempt 3. You rewrite the whole thing with modern libraries, and it fails with the exact same error. Now you're getting frustrated. So for attempt 4, you just burn it all down and reinstall the entire environment from scratch. And it still fails. It was never the code.
And here it is, the painful conclusion. The problem couldn't be solved with more code or better code because the environment itself was just broken. It was corrupted deep down at the operating system level, you see? No amount of clever coding was ever going to fix a busted foundation.
And that's the big takeaway here. The real work of building AI isn't just about writing cool algorithms. It's about being an architect. It's about building and managing the complex and often really fragile infrastructure that allows all that cool code to even run in the first place.
So we've got our factory, we get how hard it is to actually build and maintain it. Now for the big question, how do you turn this thing into a business? How does all this data processing turn into actual dollars?
Well, a great factory can produce a whole range of products. You can sell those curated data sets we talked about. You could sell specialized prompt packs for different industries. You could even offer services like scrubbing personal information from data, training custom LLMs for other companies, or selling safety systems to keep other AIs in line.
And the business models are super flexible. You could do something as simple as selling data by the gigabyte, or you could have monthly subscriptions for your data pipelines, or you could go all the way up to selling full-service enterprise solutions to big companies.
So, if you're out there thinking about building one of these systems, here's a quick guide. Step 1, start by defining the overall goal, not just a single prompt. Step 2, give your system a tool belt, access to APIs, databases, whatever it needs to do its job. Step 3, make sure you build in that crucial reflection loop so it can self-correct. And finally, step 4, set the guardrails. Always have a human in the loop for the big decisions.
Which really brings us to the final thought. The whole conversation around AI is changing. The future isn't just about getting good at prompting. It's about getting good at building the factories. So I guess the question for you is, are you a prompter or are you an architect? Thanks for joining us.